how do we communicate optimization problems from one person to another? How does a person communicate an optimization problem to a computer? How do two computer programs communicate optimization problems to each other? Let's take a look at all the different ways we can do that. One obvious one is via word problems. Someone walks into an office or meets someone on the street or something and says, I have this optimization problem. I need to do this, and here's my constraints, and here's my here's my objective function. That could be in a textbook. It could be between business teams or something. Obviously, we can communicate them via solver by setting up some products, telling solver stuff in the dialog box, and if you're smart, maybe even doing some color coding, although solver doesn't really care about that. We might communicate them by writing down explicit values and variables. So minimize this. ST often stands for subject to or such that. It means here comes the constraints. I just made up this kind of abstract problem. Is there anything missing from this that we would usually write? You might say all variables non-negative. Maybe you don't need that, but maybe you do. Now that this is in such nice rows and columns, let's think about how we might write this with linear algebra. We might say let x, the vector x, I'm going to write LaTeX notation, but just imagine it's an x with a vector hat over it. That might be the variable x and the variable y as scalars stacked into a column. What other vectors and stuff might we have here? So we've got x, y. We've got costs, maybe if we're minimizing costs, like 3 and 2. So we might say the vector c is 3, 2. So these are column vectors. Do we have any other vectors here? Well, the right-hand side, 11.2 and 23, we often call that B, and again, that would be a column vector. Anything else going on in this problem? Well, we've got coefficients there, and we've got 3 rows of them and 2 columns of them, so that would be a matrix, right? So I'll say the matrix A is 5, 7, that's one row, 11, 3, that's another row, 5, 9 is another row, and that's a 2-row, a 3-row, 2-column matrix. And then how can we put that all together into an optimization problem? We might say minimize C transpose times X as vectors. I'm not going to type that though. Subject to, what's a way of writing our constraints like this? Well, we've got the matrix A times the vector xy, so AX greater than or equal to vector B, and all variables non-negative, which you could write as vector x greater than or equal to 0. So writing it in linear algebra lets us do really interesting things later. Right now it doesn't seem like a massive improvement over that, but it's important to be able to think of this in terms of vectors and matrices and stuff. What else can we do to communicate optimization problems? We can use something called sets, indices, and summation notation. I'll just show a little preview of that here, where we're defining variables and I and j index the cities, and then we're summing over this and summing over that. That kind of stuff can be expressed in text to things called optimization modeling languages. There's some that cost money, and then there's some that are free, and we'll do those in a video another day. Linear programs were even communicated from people to machines and machines to machines in punch card days using something called MPS files. And even some of the software these days, I think most linear programming software can still read MPS files. Some will generate MPS files. And for the hardcore coders, you can use C++ and Java interfaces to set up loops to define constraints and variables and stuff. So next we'll talk more about sets and indices and summation notation and modeling languages. next video.